Dear learners, Assalamu alaikum. I wholeheartedly invite all of you to watch the video. Our today's topic is Linear Programming Part 2. Learning outcomes. At the end of the class, the learners will be able to 1. Solve the two important types of linear programming problems. 2. Describe the conditions of linear programming problems. 3. Know and answer the two important exceptional questions. Main space on the topic. Question 1. With the help of graph, find the maximum value of z is equal to twice x plus thrice y. Under the conditions, x less than or equal to 4, x plus twice y less than or equal to 10, x plus y less than or equal to 6, x, y greater than or equal to 0. It's a linear programming problem. In the last class, on the topic linear programming part 1, I had given focus on the 5 steps of forming a linear programming problem and on its solution. Dear learners, make these 5 steps clear comparing with such questions, such as first step is to choose the deciding variables. X and Y are deciding variables here. Second step is to write the objective function. Z is equal to twice x plus thrice y is the objective function which is to be maximized. Third step is to form the linear inequalities. X less than or equal to 4, x plus twice y less than or equal to 10, x plus y less than or equal to 6. These linear inequalities are formed here. Fourth step is to express the non-negative factors as non-negative linear inequalities if exist. X, y greater than or equal to 0 are the non-negative linear inequalities. The fifth step is to express as linear programming problem. This question is made as a fifth step. These steps will be made more clear when we apply the first 3 steps in for next question. However, 1, 2, 3, 4, 5 linear inequalities are given in the question. We should write first their corresponding straight lines and then draw their graphs in the sheet of graph paper and then find out their feasible region, because the maximum or minimum value will always be at any corner point of the feasible region. Except one exceptional case, I will certainly discuss about this exceptional case in this class. Let us start to solve. Solution. Corresponding lines are x is equal to 4, number 1, which is taken from the first linear inequality, x less than or equal to 4. X plus twice y is equal to 10, number 2, which is taken from the second linear inequality, x plus twice y less than or equal to 10. X plus y is equal to 6, number 3, which is taken from the third linear inequality, x plus y less than or equal to 6. X is equal to 0, number 4, y is equal to 0, number 5. Both are taken from the combination of the last linear inequalities. In the line 1, there is a single variable x is equal to 4 and the ordinate on the x-axis is always 0. That's why the line 1 passes through the point A40 and parallel to the y-axis. The line 2 passes through the points B10 and C05. A question may be arising in you. How does this straight line pass through the points B10 and C05? Dear learners, if you put y is equal to 0 into, then you will get x is equal to 10. And as well, you will get the point as B10. Again, if you put x is equal to 0, then you will get twice y is equal to 10, therefore y is equal to 5. And you will get the point as C05. In the same way, the line 3 passes through the points D60 and E06. The lines 4 and 5 are respectively the y and x axis. In case of drawing any graph, the x and y axes are always to draw the sheet of graph paper. That's why we have to draw the remaining straight line 1, 2, and 3 by plotting these points. Let us now draw their graphs. Assuming the length of one side of the smallest square as 1 unit with respect to the axes x o x prime and y o y prime. We plot the points A40, B10, C05, D60, E06 on the graph paper. In order to plot these points on the graph paper, let us take a sheet of graph paper and then draw the axis x o x prime and y o y prime. Since the coordinate of the point A40 is 0, that's why the point A40 will be on the x-axis. Again, since one unit is considered as one side of the smallest square or one smallest square, therefore 4 units will be as 4 smallest squares. That's why the point A40 will be on the x-axis. After 4 smallest squares from the origin along the positive direction of the x-axis. This origin 1, 2, 3, 4 smallest square along the positive direction of the x-axis. Similarly, the point B10 will be on the x-axis after 10 smallest squares from the origin along the same direction of the x-axis. The axis of the point C05 is 0, that's why it will be on the y-axis. Since one unit is considered as one smallest square, that's why 5 units will be as 5 smallest squares. That's why the point C05 will be on the y-axis after 5 smallest squares from the origin along the upper direction of the y-axis. In the same way, the point D60 will be on the x-axis after 6 smallest squares from the origin along the positive direction of the x-axis. And finally, the point E06 will be on the y-axis after 6 smallest squares from the origin along the upper direction of the y-axis, or the positive direction of the y-axis. And we draw the lines AL, BC, and DE. The lines 1 and 2 intersect each other at the point P42 and the lines 2 and 3 intersect each other at the point Q to 4. Let us now find out the feasible region. If we put the base test point 0, 0 on the left side of the linear inequality x less than or equal to 4, then we'll get 0 less than or equal to 4, which is true. That's why the half plane represented by x less than or equal to 4 will be on the origin side. In another way, you can express it. X is equal to 4 is on the line AL, and all the values of less than 4 will be on the left side of line AL, which is the origin side. That's why the half plane represented by x less than or equal to 4 will be on the origin side of line AL. If we put the base test point 0, 0 on the left hand side of the linear inequality x plus twice y less than or equal to 10, then you will get 0 less than or equal to 10, which is true. That's why the half plane represented by x plus twice y less than or equal to 10 will be on the origin side of base C. Similarly, the half plane represented by x plus y less than or equal to 6 will be on the origin side of the line DE. Since all the non-negative values of x will be on the right side of the y-axis, that's why half plane represented by x greater than or equal to 0 will be on the right side of the y-axis. Since all the non-negative values of y will be above the x-axis, that's why the half plane represented by y greater than or equal to 0 will be above the x-axis. The arrow signs indicate that O, A, P, Q, C is the feasible region. So each point of the region O, A, P, Q, C satisfies the given linear inequalities, and so O, A, P, Q, C is the feasible region, whose corner points are O00, A40, P42, Q24, and C05. In order to find the maximum value of Z, we now find the values of Z at these corner points. We observe that corner point x, y, value of Z is equal to twice x plus thrice y. At the corner point O00, Z is equal to 2 into 0 plus 3 into 0, as x and y are both 0, is equal to 0. At the corner point A40, Z is equal to 2 into 4 plus 3 into 0, as x is 4 and y is 0, is equal to 8. At the corner point P42, Z is equal to 2 into 4 plus 3 into 2, as x is 4 and y is 2, is equal to 14. At the corner point Q24, Z is 2 into 2 plus 3 into 4, as x is 2 and y is 4, is equal to 16. At the corner point C05, Z is 2 into 0 plus 3 into 5, as x is 0 and y is 5, is equal to 15. From the above table, it is clear that the maximum value of Z is 16. Hence, the required maximum value of Z is 16. Question 3. A man wants to plant at least 12 coconut and 8 mango saplings in his garden. The cost of each coconut and mango sapling are respectively taka 20 and taka 30. By investing an amount not exceeding taka 600, how many of each kind can he purchase so that the total number of saplings may be maximum? This problem should be expressed as linear programming problem in brief by the steps of forming as linear programming problem. Let us start to solve. Solution. First step is to choose the deciding variables. So let total number of purchasing coconut and mango saplings be x and y respectively. Second step is to write the objective function. Since the total number of saplings is x plus y, which is to be maximized, that's why objective function f is equal to x plus y, which is to be maximized. Third step is to form the linear inequalities. The number of coconut saplings is at least 12. That's why we can write x greater than equal to 12. Again, the number of mango saplings is at least 8. That's why we can write y greater than equal to 8. We now determine the total cost of coconut and mango saplings. The cost of one coconut sapling is taka 20. Therefore, the cost of x coconut saplings is taka 20x. Similarly, the cost of y mango saplings is taka 30y. The total amount is taka 20x plus 30y, which will not exceed taka 600. That's why we can write 20x plus 30y less than or equal to 600. Since there is a common factor 10, that's why dividing both sides by 10 we get twice x plus thrice y less than 60. Fourth step is to express the non-negative factors as non-negative inequalities if exist. Since x greater than or equal to 12 and y greater than or equal to 8, that's why fourth step does not exist here. The fifth step is to express as linear programming problem. This is as a fifth step. However, the corresponding straight lines are x is equal to 12, number 1, which is taken from the first linear inequality x greater than or equal to 12. Y is equal to 8, number 2, which is taken from second linear inequality y greater than or equal to 8. Twice x plus thrice y is equal to 60, number 3, which is taken from the third linear inequality twice x plus thrice y less than or equal to 60. In the line 1, there is a single variable x is equal to 12 and the ordinate on the x-axis is 0. That's why the line 1 passes through the point A, 12, 0 and parallel to the y-axis. In the line 2, there is a single variable y is equal to 8 and the axis on the y-axis is 0. That's why the line 2 passes through the point B08 and parallel to the x-axis. The line 3 passes through the points C30 and D020. If you put y is equal to 0, then we will get twice x equal to 60, therefore x is equal to 30. you will get the point as C30. Similarly, if you put x is equal to 0, then you will get thrice y is equal to 60, therefore y is equal to 20. And you will get the point as D020. Assuming the length of one side of the smallest square as 2 units with respect to the axis x of x prime and y prime. We plot the points A12, and B08, C30, and D020 on the graph paper. For plotting this point, let us take a sheet of graph paper and then draw the axis x o x prime and y o y prime. If the ordinate of a point is 0, then this point will be on the x-axis. If the abscissa of a point is 0, then it will be on the y-axis. Since 2 units is considered as one side of the smallest square, therefore 1 unit will be as half of the smallest square. Therefore, 12 units will be as 12 by 2 or 6 smallest squares. Similarly, 8 units will be as 4 smallest squares. 30 units will be as 15 smallest squares. And finally, 20 units will be as 10 smallest squares. Thus, the point A12 will be on the x-axis after 6 smallest squares from the origin along the positive direction of the x-axis. The point B08 will be on the y-axis after 4 smallest squares from the origin along the upper direction of the y-axis. The point C30 will be on the x-axis after 15 smallest squares from the origin along the positive direction of the x-axis. And finally, the point D020 will be on the y-axis after 10 smallest squares from the origin along the upper direction of the y-axis. And draw the lines AL, BM, CD. The lines 1 and 2 intersect each other at the point E. The lines 2 and 3 intersect each other at the point Q. And the lines 1 and 3 intersect each other at the point R. Let us now find out the feasible region. First, linear inequality. X is equal to 12 will be on the line AL. And all the values greater than 12 will be on the right side of AL. And it is the non-origin side of AL. That's why the half plane represented by the linear inequality x greater than or equal to 12 will be on the non-origin side of AL. Similarly, y is equal to 8 will be on the line BM, and all the values greater than 8 will be on the upper side of BM. It is also the non-origin side of BM. That's why the half plane represented by y greater than or equal to 8 will be on the non-origin side of BM. If we put the base test point 0, 0 on the left hand side of the linear inequality, twice x plus thrice y less than or equal to 60, then we will get 0 less than or equal to 60, which is true. That's why the half plane represented by the linear inequality twice x plus thrice y less than or equal to 60 will be on the origin side. The arrow signs indicate PQR is the feasible region. It is a right angle triangle whose base is parallel to the x-axis and height is the parallel to the y-axis. Since x is the number of coconut saplings greater than or equal to 12 and y is the number of mango saplings greater than or equal to 8, that's why x and y are both positive integers. In this exceptional case, the maximum value will be on the hypotenuse of the right angle triangle. However, we should write clearly its point of the region PQR satisfies the given linear inequalities, and so PQR is the feasible region. From above, we can easily write y is equal to 60 minus twice x by 3 greater than equal to 8. X greater than equal to 12. Let us explain how we can have this. Twice x plus thrice y is equal to 60. This implies thrice y is equal to 60 minus twice x, transposing the term twice x from the left hand side to the right hand side. Therefore, y is equal to 60 minus twice x by 3, dividing both sides of it by 3. Also, in the second linear inequality, we are given y greater than equal to 8. Combining these two, we get y is equal to 60 minus twice x by 3 greater than equal to 8. And in the first linear inequality, x greater than equal to 12 is given. With this, we now determine the possible values of x and y. 1. When x is equal to 12. Y is equal to 60 minus 2 into 12 by 3. This implies that y is equal to 36 by 3. That's why y is equal to 12. 12 is an integer and greater than 8. That's why y is equal to 12 is acceptable. That's why when x is equal to 12, y is equal to 12. Dear cadets, a question may be arisen in you, why we started with x is equal to 12? Since the values of x can never be less than 12. That is why we have started with x is equal to 12. When x is equal to 13, y is equal to 60 minus 2 into 13 by 3. This implies that y is equal to 34 by 3. Therefore, y is equal to 11.33. This value is not an integer. That's why it is not acceptable. When x is equal to 14, y is equal to 60 minus 2 into 14 by 3. This implies that y is equal to 32 by 3. Therefore, y is equal to 10.66. This is not an integer. This is not acceptable. When x is equal to 15, y is equal to 60 minus 2 into 15 by 3 implies that y is equal to 30 by 3. Therefore, y is equal to 10. 10 is an integer and greater than 8. That's why the value of y is acceptable here. Number 2, when x is equal to 15, y is equal to 10. When x is equal to 16, y is equal to 60 minus 2 into 16 by 3. This implies that y is equal to 28 by 3. Therefore, y is equal to 9.33. It is not an integer. That's why this value is not acceptable. When x is equal to 17, y is equal to 60 minus 2 into 17 by 3. This implies that y is equal to 26 by 3. Therefore, y is equal to 8.66. This is not an integer. And this value of y is not acceptable. When x is equal to 18, y is equal to 60 minus 2 into 18 by 3. This implies that y is equal to 24 by 3. Therefore, y is equal to 8. It is an integer and it is the highest value of y. That's why y is equal to 8 is acceptable. Number 3, when x is equal to 18, y is equal to 8. When x is equal to 19, y is equal to 60 minus 2 into 19 by 3. This implies that y is equal to 22 by 3. Therefore, y is equal to 7.33. It is not an integer and less than 8. That's why we have to stop here. We now observe that when value of f is equal to x plus y, and x is equal to 12, y is equal to 12, f is equal to 12 plus 12 is equal to 24. When x is equal to 15, y is equal to 10, f is equal to 15 plus 10 is equal to 25. When x is equal to 18, y is equal to 8, f is equal to 18 plus 8 is equal to 26. From the above table, it's clear that maximum value of f is 26. When the value of f is maximum, the values of x and y are respectively 18 and 8. Hence, the required number of coconut and mango saplings are 18 and 8 respectively. Dear learners, the 5 steps of forming linear programming problem will help you make the conditions of linear programming clear. Conditions of linear programming. Number 1, there must have a problem describing some conditions. When you apply the steps of formation, problem is given with some conditions. 2, the variables satisfying the given conditions should be interrelated and expressible as a system of linear inequalities. In the third steps, linear inequalities are expressed with some interrelated variables. 3, there must have a linear function expressed in terms of the variables of the inequalities, and it is to be maximized or minimized. It is nothing but objective function. Number 4, there must have some alternatives with limited resources for achieving the desired goal. The question, there are some limited resources and some alternatives. With this, the desired goal is to be achieved. Question 1, what is linear programming? Write down the steps for the formation of linear programming programs. Question 2, define linear programming. What are the conditions of linear programming? We discussed the answer of question 1 in our previous class in detail. And second part of question 1 is also discussed in our present class. Define linear programming is same as what is linear programming. What are the conditions of linear programming? We have just discussed about the conditions of linear programming. If you have any query after watching the video, please let me know. The answer of your question will be given very quickly with utmost sincerity. With this, I conclude here. Thanks. Best of luck.